June 6, 1944, 6 minutes past midnight, Normandy, France. The first American glider touched down in a Norman cow pasture with a grinding crash that could be heard half a mile away. Within 90 seconds, 13 fully equipped paratroopers had emerged from the wreckage and were moving toward their objective. By dawn, over 400 gliders would deliver more than 6,000 American troops directly behind German defensive lines in the largest airborne assault in military history. Standing in the concrete bunkers of the Atlantic Wall, German officers watched through periscopes and field glasses as something unprecedented unfolded before their eyes. Wave after wave of engineless aircraft were landing entire companies of infantry, complete with jeeps, anti-tank guns, radio equipment, and ammunition. What the Germans witnessed that morning violated every principle of military logistics they had learned in decades of warfare. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Traditional military doctrine held that large-scale troop movements required either massive amphibious operations with extensive naval support or overland advances with established supply lines. Yet here, American forces were delivering battalion-strength units directly to the battlefield, using nothing more than cloth and wood aircraft pulled by conventional bombers. The mathematics of the impossible were being written in real time across the fields of Normandy. For the German defenders, the psychological impact was as devastating as the tactical surprise. How could a military achieve what their own experts had declared technically unfeasible? The answer lay not in superior German engineering or tactical innovation, but in an American approach to airborne warfare that had transformed the glider from a sporting curiosity into the most efficient troop transport ever developed. The journey to that Norman cow pasture had begun 3 years earlier in a classified meeting room at Wright Field, Ohio. On September 15, 1941, General Henry Arnold, commanding general of the Army Air Forces, faced a strategic problem that conventional military thinking could not solve. The United States needed the capability to deliver large numbers of troops behind enemy lines, but existing methods were inadequate. Parachute drops, while tactically valuable, scattered troops across wide areas. Soldiers landed individually, often miles from their intended objectives. Equipment was separated from personnel. Heavy weapons like anti-tank guns and vehicles could not be delivered effectively. Amphibious landings required naval supremacy and favorable geography. Both limitations meant that American forces might face situations where rapid deployment of concentrated units was essential but impossible using conventional methods. Arnold had observed German airborne operations in Crete during May 1941. Operation Mercury, the German assault on the island, had demonstrated both the potential and limitations of paratrooper operations. German Fallschirmjäger had achieved tactical surprise and ultimately captured the island, but at devastating cost. The scattered nature of parachute drops had left German units vulnerable to counterattack while they regrouped and located their equipment. Arnold concluded that America needed a different approach. Rather than dropping individual soldiers who would then have to find each other and their equipment, he envisioned delivering complete tactical units that could fight immediately upon landing. The solution, he believed, lay in military gliders. The concept was not entirely new. Germany had used gliders for special operations, most notably the assault on Fort Epernay-Isle in Belgium during May 1940. 10 German DFS, 230 gliders had landed 78 engineers directly on top of the fortress, enabling them to disable the fort's guns with shaped charges before Belgian defenders could react effectively. The operation had been tactically brilliant but limited in scope. Arnold envisioned something far more ambitious. He wanted gliders capable of delivering not just assault troops, but entire infantry companies with their organic weapons, vehicles, and supplies. The aircraft would need to land in small fields, deliver their cargo quickly, and allow troops to begin combat operations immediately. No military had ever attempted airborne operations on such a scale. The technical requirements seemed impossible by 1941 standards. A military glider would need to carry loads exceeding anything previously attempted in engineless flight. It would have to land safely in unprepared fields while carrying troops and equipment weighing several tons. The aircraft would have to be strong enough to survive combat landings, but light enough to be towed efficiently by existing bombers. Most challenging of all, it would need to be simple enough for mass production by companies with no aviation experience. Arnold turned to the Waco Aircraft Company of Troy, Ohio. Waco had built civilian gliders and light aircraft since 1919, but had never attempted anything approaching military requirements. The company's chief engineer, Charles Chase, initially dismissed the Army's specifications as technically impossible. A glider capable of carrying 15 troops plus equipment would weigh more than existing bombers when loaded. No tow aircraft in the American inventory could handle such loads. The breakthrough came when Chase realized that conventional thinking about glider design was wrong. Instead of building a lightweight aircraft that could barely carry its load, Waco would build a robust transport that happened to have no engine. The CG-4A, which would become known as the Hadrian, represented a fundamental reimagining of what gliders could accomplish. The aircraft was enormous by glider standards. 84 feet long with a wingspan of 83 feet 8 inches, the CG-4A weighed 4,300 pounds empty and could carry 3,750 pounds of cargo. The payload included 13 fully equipped troops or a jeep with trailer and crew. The glider featured a hinged nose section that opened completely, allowing vehicles to drive directly out upon landing. Traditional glider pilots had learned to land gently, preserving their aircraft for future flights. Military glider pilots were trained to land anywhere, accepting that their aircraft would likely be destroyed in the process. The CG-4A was designed for controlled crashes. Its wooden structure absorbed impact energy through progressive failure. The cockpit was armored to protect the two pilots. Seats were positioned to minimize injury during violent landings. The first prototype flew on May 8, 1942. Test pilots reported that the aircraft handled surprisingly well despite its size. The CG-4A was stable in flight, responsive to controls, and capable of landing in remarkably short distances. When flown by experienced pilots, the glider could touch down and stop within 400 feet, even when fully loaded. But the real innovation was not the aircraft itself, but the training program that transformed civilian pilots into military glider specialists. The Army Air Forces established the Glider Pilot School at 29 Palms, California, in July 1942. The program compressed traditional flight training into 4 months of intensive instruction that emphasized practical skills over theoretical knowledge. Students learned to fly gliders before they learned to fly powered aircraft. The logic was counterintuitive but effective. Glider pilots developed exceptional feel for aircraft handling because they could not rely on engine power to compensate for mistakes. Every approach had to be perfect because there was no opportunity for a second attempt. Students who mastered gliders found powered aircraft easy by comparison. The training philosophy reflected American industrial thinking applied to military aviation. Rather than developing generalist pilots who could fly any aircraft adequately, the program created specialists who could perform one mission superbly. Glider pilots learned to read terrain, judge wind patterns, and execute precision landings under conditions that would challenge veteran aviators. Major Mike Murphy, who commanded the first operational glider squadron, described the training in a 1943 interview with Stars and Stripes. "We teach our pilots to land anywhere, anytime, in any conditions. They practice landing in plowed fields, on hillsides, in forests, at night, in bad weather. By the time they complete training, they can put a glider down safely in spaces that would terrify commercial airline pilots." The production challenge proved as demanding as pilot training. The Army Air Forces contracted for 13,000 CG-4A gliders from 16 manufacturers, most of whom had never built aircraft. Piano companies, furniture makers, and boat builders received contracts to produce components using skills adapted from their civilian specialties. The Ford Motor Company, already building B-24 bombers at Willow Run, took responsibility for final assembly of 4,000 gliders. Henry Ford initially resisted the contract, arguing that his assembly line methods were unsuited to aircraft production. He changed his mind when Army officials explained that gliders required exactly the kind of mass production techniques Ford had perfected for automobiles. The glider production program democratized aircraft manufacturing in ways that paralleled Henry Kaiser's shipbuilding revolution. Companies that had never considered aviation contracts found they could adapt existing skills to military requirements. The Commonwealth Aircraft Corporation in Kansas City, which normally built light planes, tooled up to produce glider wings. The Pratt, Red and Company, a deep-sea fishing equipment manufacturer in Connecticut, built glider fuselages using boat-building techniques. By early 1943, glider production was approaching 100 aircraft per month across all contractors. The quality was variable but acceptable. Some gliders suffered structural failures during testing, leading to improved design standards and better quality control. But the overall program succeeded in delivering thousands of aircraft that met military requirements for carrying capacity, durability, and ease of maintenance. The strategic implications became clear during planning for Operation Overlord, the Normandy invasion. Allied planners faced a fundamental problem. The Atlantic Wall represented the most formidable defensive system ever constructed. German engineers had spent 4 years creating interconnected bunkers, artillery positions, and obstacles designed to prevent exactly the kind of amphibious assault the Allies were planning. Traditional military approaches offered no solution. A direct frontal assault against prepared positions would result in casualties that might cripple the invasion before it achieved its objectives. Attempts to outflank the defenses would require naval operations that German coastal artillery could disrupt. The Allies needed a way to attack the Atlantic Wall from behind while simultaneously conducting the main assault from the sea. Airborne operations provided the answer, but only if they could deliver sufficient force to accomplish meaningful objectives. Parachute drops alone could not provide the combat power necessary to seize and hold key terrain features. The Americans needed to land entire battalions with their organic weapons and equipment. Gliders made this possible. The plan that emerged called for the largest airborne operation in military history. 2 American airborne divisions, the 82nd and 101st, would land behind Utah Beach, beginning at 1:30 a.m. on D-Day. The operation would involve 821 transport aircraft, dropping 13,400 paratroopers, followed by 512 gliders delivering an additional 4,012 troops with vehicles, artillery, and supplies. The glider component of the operation represented capabilities that no military had ever possessed. Each CG-4A could deliver a 13-man rifle squad with organic weapons including bazookas, mortars, and machine guns. Larger Waco CG-13 gliders could carry 30 troops or a 75mm howitzer with crew and ammunition. The British Horsa gliders assigned to the operation could deliver an entire platoon of infantry with jeeps and trailers. For German defenders, the scale of the airborne assault was incomprehensible, using their understanding of military logistics. The Luftwaffe had attempted similar operations, but never achieved the concentration of force that Allied gliders were delivering. German airborne doctrine emphasized small-scale raids and special operations. The concept of landing multiple battalions simultaneously exceeded their operational planning assumptions. General der Artillerie Erich Marx, commanding the 84th Corps responsible for defending the Cotentin Peninsula, had studied Allied airborne capabilities extensively. His intelligence reports, captured after the war, revealed German assumptions about glider operations that proved dramatically wrong. Marx calculated that Allied gliders could deliver perhaps 500 to 1,000 troops in scattered groups that could be defeated in detail by mobile reserves. His defensive plans assumed that airborne forces would require hours to organize after landing, providing time for German counterattacks to eliminate them before they could establish cohesive positions. The reality proved utterly different. American glider pilots had trained to land in formations that preserved unit integrity. Entire companies landed within a few hundred yards of each other, enabling immediate tactical coordination. Pre-positioned equipment meant that anti-tank guns and mortars were operational within minutes of landing. Radio communications allowed dispersed units to coordinate operations across wide areas, The psychological impact on German troops was as significant as the tactical surprise. Soldiers defending coastal positions found themselves under attack from behind by forces that seemed to have materialized from nowhere. The presence of American vehicles and artillery pieces inland from the beaches suggested that the invasion was succeeding on a scale that German commanders had not anticipated. Obergefreiter Hans Wagner of the 91st Infantry Division wrote in his diary on June 7, 1944, "Yesterday at dawn we saw the enemy aircraft overhead, but thought they were bombers returning from raids inland. Then we realized some had no engines and were landing in the fields behind us. Within an hour, American troops with vehicles and guns were attacking our positions from directions we never expected. How can they move such forces through the air?" The technical achievements that enabled this strategic surprise reflected American industrial capabilities applied to military problems with characteristic innovation. The CG-4, a glider, represented engineering solutions that balanced competing requirements through systematic compromise. The aircraft was not elegant, but it was effective. It sacrificed performance for payload, refinement for ruggedness, and cost for capability. Production statistics reveal the scale of the American commitment to glider operations. Between 1942 and 1945, American manufacturers delivered over 13,000 military gliders of all types. The CG-4A alone accounted for nearly 12,000 aircraft, making it one of the most numerous military aircraft ever produced. Peak production reached 300 gliders per month in early 1944. The human cost of glider operations was significant but acceptable by wartime standards. Glider pilots faced mortality rates approaching those of bomber crews. Landing in combat zones with no possibility of powered flight meant that pilot survival often depended on luck as much as skill. Of the 512 gliders launched during the Normandy operation, approximately 80 were destroyed on landing with casualties among both pilots and passengers. Yet, the strategic value justified the risks. Glider operations in Normandy enabled the rapid seizure of key terrain features that might otherwise have required days of costly ground combat to capture. The Douve River bridges, essential for linking Utah Beach with inland objectives, were secured by glider-borne troops hours before seaborne forces could have reached them overland. The cumulative effect was decisive. German reserves positioned to counterattack the beach landings found themselves engaged with airborne forces that prevented effective concentration against the amphibious assault. By the end of D-Day, Allied forces had established beachheads that could not be eliminated by conventional counterattack. The airborne operations had achieved their strategic objective of disrupting German defensive responses during the critical first hours of the invasion. For the German officers who witnessed these operations, the implications extended far beyond the immediate tactical situation. American glider capabilities represented industrial and organizational advantages that Germany could not match. The ability to produce thousands of specialized aircraft, train thousands of pilots, and coordinate complex multi-division airborne operations demonstrated capabilities that revealed fundamental differences in how the two sides approached warfare. The story of American glider development and deployment illustrates principles that characterized the broader American approach to World War II. Technical problems were solved through systematic engineering and mass production rather than individual brilliance. Training programs emphasized practical skills and standardized procedures rather than traditional military formality. Strategic planning integrated new capabilities with existing forces to achieve objectives that conventional methods could not accomplish. Most significantly, American glider operations demonstrated the democratic military's ability to innovate rapidly when necessity demanded it. From General Arnold's initial concept in September 1941 to the Normandy landings in June 1944, the United States had created an entirely new form of warfare in less than 3 years. The organizational and industrial mobilization required for this achievement exceeded anything Germany had accomplished in similar timeframes. The German reaction to American glider capabilities reveals the psychological dimension of military innovation. Technical surprise affects enemy morale as much as enemy capabilities. When established military powers encounter tactics they cannot easily counter, the result is often doctrinal confusion that persists long after effective responses might have been developed. General Marx spent the weeks following D-Day revising German defensive planning to account for airborne capabilities he had not anticipated. His reports to higher headquarters requested anti-aircraft units, mobile reserves, and fortifications designed to counter glider landings. But by then, the strategic initiative had passed permanently to the Allies. German defensive improvements could not restore the advantage of surprise that had been lost on June 6. The technical specifications of the CG-4A reveal the engineering challenges that American manufacturers overcame to create effective military gliders. The aircraft's gross weight of 8,050 pounds, when fully loaded, exceeded that of many powered aircraft in 1942. The wing loading of approximately 24 pounds per square foot was higher than most contemporary fighters, requiring approach speeds that left little margin for error during landing. Yet the glider's structural design absorbed tremendous abuse while protecting its occupants. The wooden construction, initially criticized as primitive compared to metal aircraft, proved ideal for absorbing crash forces through progressive failure. The fabric-covered control surfaces remained effective even after severe damage. The tricycle landing gear, unusual for military aircraft of that era, provided stability during ground operations in rough terrain. The morning of June 6, 1944, would prove whether American innovation could overcome German defenses in the most demanding test possible, actual combat. As the first transport aircraft crossed the English Channel towing their engineless cargo, both sides would discover what glider warfare meant when theory met reality. Flight Officer John Butler of the 361st Fighter Group had volunteered for glider pilot training in late 1942, drawn by promises of adventure and the chance to participate directly in ground combat. At 23 years old, he possessed exactly the combination of flying skill and tactical judgment the Army Air Forces sought in glider pilots. His CG-4A carried 13 paratroopers from the 502nd Parachute Infantry Regiment, along with a jeep, trailer, and ammunition. Butler's mission typified the precision required for successful glider operations. His designated landing zone measured barely 400 yards square, surrounded by tall hedgerows that could destroy his aircraft if approached incorrectly. The field lay 2 miles, inland from Utah Beach, close enough to support the amphibious assault, but far enough to avoid German coastal artillery. His passengers would secure a crossroads that Allied planners considered essential for linking beach forces with airborne objectives. The approach began at 3,000 feet over the Channel Islands. Butler's tow aircraft, a Douglas C-47, maintained exactly 160 miles per hour to optimize fuel consumption while providing adequate lift for the heavily loaded glider. The nylon tow rope, 350 feet long and capable of withstanding 8,000 pounds of tension, connected the two aircraft in a relationship that required constant attention from both pilots. Glider towing demanded skills that conventional flight training did not provide. The C-47 pilot had to account for the additional drag and weight of his engineless cargo while maintaining formation with dozens of other aircraft in the pre-dawn darkness. Any sudden maneuver could snap the tow rope or cause the glider to stall. Radio communication between aircraft was forbidden to maintain tactical surprise, forcing pilots to coordinate through visual signals and predetermined procedures. Butler monitored his instruments carefully as the formation crossed the French coast. Airspeed, altitude, and tow rope tension had to remain within narrow parameters to prevent structural failure. The glider's gross weight of 8,050 pounds when fully loaded created tremendous stress on the wooden airframe during any maneuvering. Too much speed would overstress the wings. Too little would cause a stall that could be fatal at low altitude. The release point came at exactly 02:15 hours, precisely as briefed. Butler pulled the release handle, felt the sudden slack as the tow rope fell away, and immediately began his approach to the designated landing zone. From 3,000 feet, he had perhaps 4 minutes to identify his target, set up his approach, and execute a landing that would preserve both aircraft and passengers. The challenges multiplied in darkness. Landing zones that appeared adequate in daylight photography proved deceptively small when approached at 80 miles per hour in a fully loaded glider. Obstacles invisible in reconnaissance photos became deadly hazards. Power lines, ditches, Anti-glider stakes and farm equipment could destroy an aircraft instantly. German defenders had spent months preparing these exact fields as traps for Allied airborne forces. Butler identified his target field by landmark navigation, using church steeples and road intersections visible in the moonlight. The hedgerows that characterized Norman agriculture created natural boundaries, but they also represented deadly obstacles that could decapitate unwary pilots. Approach angles had to be calculated precisely to clear obstacles, while maintaining sufficient speed for controllability. The actual landing proved anticlimactic after months of training and worry. Butler flared his glider at exactly the right moment, touched down in the field's center, and ground-looped slightly to dissipate energy quickly. The aircraft came to rest after rolling less than 200 feet. Within 90 seconds, his passengers had exited through the hinged nose section and were moving toward their objective with their equipment intact. Similar scenes unfolded across the Cotentin Peninsula as more than 500 gliders delivered their cargo behind German lines. The scale of the operation overwhelmed German defensive planning. Oberst Gunther Kehl, commanding the 91st Infantry Division's Reserve Regiment, received reports of glider landings from 17 different locations within his sector. His tactical reserves, positioned to counterattack a single major airborne landing, found themselves facing multiple simultaneous threats across a front of more than 20 miles. The precision of American glider operations surprised. German commanders who had expected scattered, ineffective landings that could be defeated in detail. Instead, they encountered coordinated company and battalion-sized units that established defensive positions immediately and began offensive operations within hours of landing. Radio intercepts revealed German confusion about the scope and effectiveness of the airborne assault. General Major Wilhelm Falle, commanding the 91st Infantry Division, attempted to reach his command post near Picoville to coordinate the defense. His convoy was ambushed by paratroopers from the 507th Parachute Infantry Regiment, who had landed barely 2 hours earlier. Falle was killed instantly, becoming the highest-ranking German casualty of D-Day. The death of a division commander within hours of the invasion's start demonstrated how effectively airborne forces had disrupted German command and control. The tactical innovations that enabled successful glider operations went far beyond aircraft design and pilot training. American planners had developed systematic approaches to problems that had seemed insoluble using conventional military methods. The challenge of delivering vehicles and heavy weapons by air required rethinking fundamental assumptions about airborne warfare. Traditional parachute operations scattered equipment across wide areas, forcing troops to locate and assemble their weapons after landing. This approach worked for small-scale raids but proved inadequate for sustained combat operations. Gliders solved the problem by delivering complete tactical units with organic equipment intact and immediately available. The Waco CG-13A, a larger glider developed specifically for heavy cargo, could deliver a 75mm pack howitzer with crew and 40 rounds of ammunition. The artillery piece was assembled and ready for action within 15 minutes of landing. German defenders found themselves under accurate artillery fire from positions that they had not anticipated, delivered by forces that conventional logistics could not have supplied so rapidly. Jeeps delivered by glider provided mobility that transformed airborne operations from static defensive missions into offensive maneuver warfare. Each CG-4A could carry a quarter-ton truck with trailer, giving infantry units tactical mobility previously available only to mechanized forces. Road networks that German planners expected to control became highways for American forces, moving between objectives faster than defenders could respond. Communication equipment delivered intact by glider enabled coordination between widely separated units that would have been impossible with scattered parachute drops. Radio sets that required careful handling could be transported safely in glider cargo compartments, then deployed immediately upon landing. Within hours of the initial assault, American airborne forces had established communication networks that allowed division-level coordination of operations across the entire Cotentin Peninsula. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The medical capabilities delivered by glider transformed airborne operations from missions with limited casualty evacuation to sustained combat operations with full medical support. Specially equipped gliders carried complete field hospitals, including surgeons, medical supplies, and even portable X-ray equipment. Wounded soldiers who might have died from lack of medical attention in conventional airborne operations received treatment comparable to rear-area medical facilities. These innovations accumulated to create capabilities that exceeded the sum of their parts. German intelligence had studied individual aspects of American airborne development, but failed to appreciate how systematic integration would multiply effectiveness. A parachute regiment was a raid force. An airborne division delivered by glider was an army capable of sustained independent operations. The psychological impact on German troops proved as significant as the tactical advantages. Soldiers defending fixed positions suddenly found themselves surrounded by mobile forces that possessed capabilities conventional defensive planning had not anticipated. The presence of American vehicles, artillery, and radio communications behind German lines suggested that the invasion was succeeding on a scale that challenged fundamental assumptions about defensive warfare. Unteroffizier Kurt Mellon of the 715th Infantry Regiment wrote in a letter to his wife, dated June 8, 1944, "The Americans land complete armies from the sky. We see their trucks and guns appearing where no trucks and guns should be. How can we fight an enemy who moves through the air as easily as we move on roads? Our officers tell us to hold our positions, but the enemy is already behind us." The technical achievements that enabled these psychological effects reflected American organizational capabilities as much as engineering innovation. The coordination required to launch more than 500 gliders simultaneously, deliver them to precise landing zones, and enable immediate tactical coordination represented military planning on a scale that few armies had attempted. Each glider pilot carried detailed maps, photographs, and written instructions for his specific mission. Landing zones were designated by code names and grid coordinates. Alternate targets were provided in case primary zones proved unsuitable. Rally points were established where troops from different gliders could assemble if separated during landing. Communication procedures enabled immediate contact with higher headquarters. The systematic approach to pilot training that produced these capabilities reflected American industrial thinking applied to military education. Rather than developing generalist aviators who could fly any aircraft adequately, the program created specialists who could perform specific missions superbly. Glider pilots learned to read terrain, judge wind patterns, and execute precision landings under conditions that would challenge veteran commercial aviators. Flight Officer Robert Anderson of the 434th Troop Carrier Group exemplified the specialized expertise the program developed. Anderson had completed 4 months of intensive training at the Army Air Force's glider school, logging over 300 hours in CG-4A aircraft. He could land a fully loaded glider in a 400-foot field, execute emergency procedures that would save his aircraft after engine failure in the tow plane, and coordinate with ground forces immediately after landing. Anderson's mission on D-Day involved delivering a 13-man reconnaissance squad to a landing zone near Sainte-Mère-Église. The squad's objective was to secure a bridge over the Murderet River and establish a blocking position against German counterattacks. The bridge was essential for linking forces landing at Utah Beach with airborne units scattered across the Cotentin Peninsula. The approach proved more challenging than training had prepared him for. German anti-aircraft fire forced his tow aircraft to take evasive action, causing the glider to yaw violently at the end of its rope. Anderson fought to maintain control, as tracer rounds passed close enough to see individual bullets. The release came 2 miles from his intended landing zone, forcing him to navigate cross-country in darkness while under fire. Anderson identified an alternate field using landmarks he had memorized during briefings. The field was smaller than optimal and surrounded by obstacles, but it offered the only safe landing opportunity within reasonable distance of his objective. He executed a steep approach that brought his glider over power lines with inches to spare, touched down hard but safely, and delivered his passengers within walking distance of their assigned bridge. The squad was in position and ready for combat within 20 minutes of landing. They secured the bridge against a German patrol that arrived an hour later, established radio contact with division headquarters, and held their position until relieved by seaborne forces the following day. Anderson's mission typified the precision and effectiveness that American glider operations achieved despite challenging conditions. Similar successes occurred across the battlefield, as hundreds of glider pilots delivered their cargo with accuracy that exceeded pre-war planning assumptions. The landing zones designated for airborne operations covered approximately 100 square miles of Norman countryside. Within this area, American forces established dozens of strong points that controlled key terrain features, road networks, and communication nodes. The cumulative effect disrupted German defensive planning so thoroughly that effective counterattacks became impossible. Reserves positioned to eliminate a single major airborne landing found themselves facing multiple threats that exceeded their capacity to engage simultaneously. Units that attempted to move toward the beach to oppose the amphibious assault encountered airborne forces, blocking movement routes. Major Wolfgang Pickert, operations officer for the 709th Infantry Division, spent D-Day attempting to coordinate a counterattack against American airborne forces. His situation reports, captured after the war, revealed the extent of German tactical confusion. Pickert's division received contradictory orders to eliminate airborne landings east of the Murderate River, while simultaneously reinforcing coastal defenses against the amphibious assault. When Pickert attempted to move his reserves toward the coast, they encountered American paratroopers who had seized road junctions and established blocking positions. When he redirected forces to clear these obstacles, his units found themselves under artillery fire from guns that had been delivered by glider and positioned during the night. Every tactical decision created new problems that conventional defensive doctrine could not solve. The strategic implications extended far beyond the immediate tactical situation. German defensive planning for the Atlantic Wall had assumed that Allied forces would require days or weeks to build up sufficient strength inland to threaten major German positions. The assumption proved false when airborne forces delivered by glider established significant combat power behind German lines within hours of the invasion's beginning. General der Artillerie Erich Marx, commanding the 84th Corps, recognized immediately that the airborne assault had fundamentally altered the strategic situation. His morning report to 7th Army headquarters stated, "Enemy airborne forces have achieved tactical surprise on a scale that threatens the integrity of our coastal defense. Their capability to deliver heavy weapons and vehicles by air enables sustained operations that our planning did not anticipate." Marx requested permission to withdraw his coastal reserves to deal with the airborne threat, but Supreme Command West refused, insisting that the beach defenses must be held at all costs. The result was strategic paralysis as German forces found themselves unable to concentrate effectively against either the airborne or amphibious threats. Resources divided between multiple objectives proved inadequate for either mission. The technical specifications of American glider capabilities revealed the engineering achievements that enabled these strategic effects. The CG-4A could deliver its cargo with precision, approaching that of powered transport aircraft, while requiring no landing facilities beyond an open field. The aircraft's structural design absorbed tremendous abuse while protecting occupants during crash landings that would destroy conventional aircraft. Operational statistics demonstrated effectiveness that exceeded pre-war expectations. Of the 512 gliders launched during the Normandy assault, over 400 delivered their cargo successfully within acceptable distances of designated landing zones. Equipment loss rates remained below 10% despite violent combat landings. Personnel casualties among glider passengers stayed within acceptable limits, considering the inherent risks of the operation. The human cost proved significant but justifiable by strategic standards. Glider pilots faced mortality rates approaching 20% during major operations. The engineless aircraft offered no opportunity for evasive maneuvers when under fire. Pilots who survived crashes often faced immediate ground combat with limited training and equipment. Yet volunteer rates for glider pilot training remained high throughout the war, as aviators recognized the importance of the mission. Flight Officer Charles Williams of the 314th Troop Carrier Group survived his D-Day glider mission only to be killed 3 months later during Operation Market Garden, the airborne assault on Holland. His letters home, preserved by his family and donated to the National Archives in 1968, revealed the mindset of men who accepted extreme risks for strategic objectives they understood clearly. Williams wrote to his parents on June 10, 1944, "We accomplished something here that changes how wars will be fought. We delivered an entire army behind enemy lines, using nothing but gliders and the skill of pilots who learned to fly them." The Germans never imagined such a thing was possible. Now, they know better, but the knowledge comes too late to help them. The organizational innovations that enabled glider operations influenced American military thinking far beyond airborne warfare. The systematic approach to training, the integration of specialized equipment with tactical doctrine, and the coordination of complex multi-unit operations became standard practices in subsequent campaigns. The Pacific Theater adopted similar methods for amphibious operations. European theater commanders applied the same principles to mechanized warfare. Most significantly, American glider operations demonstrated the democratic military's capacity for rapid innovation when strategic necessity demanded it. From initial concept to operational deployment, the United States had created an entirely new form of warfare in less than 3 years. The industrial mobilization, training programs, and tactical development required for this achievement exceeded similar efforts by any other military during the war. The German response to American glider capabilities revealed the psychological dimension of military innovation. When established military powers encounter tactics they cannot easily counter, the result is often doctrinal confusion that persists long after effective responses might have been developed. German commanders spent months after D-Day developing anti-glider defenses that might have been effective if implemented earlier. General Feldmarschall Erwin Rommel, commanding Army Group B responsible for defending northwestern France, requested priority allocation of anti-aircraft guns, specifically designed to counter low-flying gliders. He ordered the installation of anti-glider obstacles in fields throughout the Atlantic Wall Zone. He revised defensive doctrine to account for simultaneous threats from sea, air, and airborne forces. But these improvements could not restore the advantage of strategic surprise that had been lost on June 6. The psychological impact of witnessing impossible tactical achievements created lasting effects that influenced German morale throughout the remainder of the war. If American forces could land entire battalions from the sky, what other impossible things might they accomplish? The technological legacy of wartime glider development extended far beyond military applications. Techniques developed for building large wooden aircraft influenced post-war construction methods in civilian aviation, housing, and industrial facilities. Training programs that compressed complex skills into abbreviated courses became models for technical education in peacetime industries. Most importantly, the systematic approach to solving technical problems through organized research, development, and testing became characteristic of American engineering culture in the decades following the war. The mindset that viewed conventional limitations as starting points rather than absolute boundaries influenced industrial development across multiple sectors. The strategic implications of successful glider operations reached far beyond the Normandy campaign. Allied commanders gained confidence that airborne forces could accomplish objectives previously considered impossible. Subsequent operations in Holland, Germany, and the Pacific incorporated lessons learned from D-Day glider missions. The capability to deliver substantial forces anywhere became a permanent element of American military planning. For the German officers who witnessed American glider operations on June 6, 1944, the experience represented a fundamental challenge to their understanding of military possibility. Forces that appeared impossible by conventional standards had proven not only possible but devastatingly effective. The techniques were crude by traditional military aesthetics, but they worked. American glider pilots were not superior humans. They were ordinary aviators who had received specialized training that enabled extraordinary performance under extreme conditions. Their aircraft were not technological marvels. They were engineless transports built quickly and cheaply, using adapted industrial techniques. Yet the combination achieved results that sophisticated military organizations had declared impossible. The story of American glider warfare ultimately demonstrates that the greatest military revolutions often emerge from systematic application of ordinary capabilities rather than breakthrough technologies. Innovation comes not from perfecting existing methods, but from questioning whether existing methods represent the only possibilities. German military excellence, built on centuries of professional tradition and refined through decades of tactical development, met American industrial capability applied to military problems with characteristic directness. The result proved that traditional military wisdom, like other forms of conventional thinking, could be wrong when circumstances demanded revolutionary approaches. The morning of June 6, 1944, changed warfare permanently. American glider operations proved that logistics could be revolutionized, that tactical surprise could be achieved on strategic scales, and that impossible missions became routine when properly organized and executed. The German officers who watched entire battalions land from the sky learned that their enemies possessed capabilities that exceeded conventional military planning assumptions. Those capabilities came not from superior military tradition or individual brilliance, but from democratic society's approach to solving technical problems through systematic effort and industrial mobilization. The gliders themselves, mostly destroyed within days of landing, mattered less than what their successful employment demonstrated about American military potential. That potential, proven in Norman cow pastures on a June morning in 1944, would continue shaping military affairs for decades to come. The techniques pioneered under wartime necessity became peacetime standards that influenced airborne operations, logistics planning, and military training worldwide. The revolution that began with General Arnold's impossible vision had become the foundation for modern air mobility operations. The German officers who declared glider operations impossible learned that impossibility, like other military concepts, depended more on imagination than technology. American forces had achieved the impossible, not through magic but through engineering, organization, and the willingness to question whether accepted limitations were actually true. That lesson, demonstrated conclusively in the fields of Normandy, remains relevant wherever military organizations face challenges that conventional wisdom claims cannot be overcome. Sometimes the impossible requires nothing more than refusing to accept that it cannot be done, then systematically figuring out how to do it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.